Welcome back, everyone. So, when we talk about the energy sector's environmental footprint, we constantly hear about greenhouse gases and the global climate, right? But in today's explainer, we're zeroing in on a completely different, highly localized threat. We're digging deep into the specific air quality impacts driven by the oil and gas exploration and production sector, or what industry insiders call the E&P sector. As extraction operations increasingly bump right up against populated areas, the industry can't just focus on what's warming the planet decades from now. They actually have to answer for what's coming out of the exhaust stack today. We're going to break down the highly standardized reporting around non-greenhouse gas emissions. We'll explore these invisible threats, things like NOx, SOx, volatile organic compounds, and particulate matter, and unpack exactly what they are and why they pose such acute, localized health risks. Let's get into it. Okay, let's kick this off by asking a really crucial question that dramatically shifts our perspective here. What else is in the air? When we analyze oil and gas exploration and extraction, the public conversation and the major headlines are almost exclusively dominated by global warming, massive carbon footprints, and sweeping climate change initiatives. But for the people actually living, working, and going to school literally just down the road from these active extraction sites, there's an entirely different, much more urgent conversation happening. For a neighborhood bordering a facility, the daily reality isn't measured in decades or global temperature averages, it's measured in the very next breath. It's all about the actual air they are inhaling on a daily basis. Now, looking at this breakdown, there's a massive contrast between the sweeping global scope of greenhouse gases and the hyper-localized, immediate threat of non-GHG air pollutants. While greenhouse gases are this massive atmospheric climate issue affecting the entire planet over the span of many decades, the SASB sustainability accounting standard makes a very sharp distinction. It points out that emissions of other very specific air pollutants create significant, immediate, and highly localized health risks. These non-GHG emissions don't travel across the globe to warm the upper atmosphere. Instead, they settle right in the immediate vicinity of the extraction sites, creating acute physical risks for the local environment and the surrounding community. It's just a completely different scale of impact.
So this brings us to the specific dossier of pollutants that exploration and production companies absolutely must track. Under the stringent SASB standard, specifically metric EMEP 128.1, if you're keeping track, companies are required to disclose their direct emissions of 4 very specific air pollutants. And, this is key, they have to measure and report these atmospheric releases in metric tons per pollutant. Using metric tons is incredibly deliberate here. It basically strips away vague estimations and forces companies to provide hard, quantifiable data on massive volumes of invisible gases. It means we can finally put a number on what was previously unseen. So what exactly are these 4 heavily monitored pollutants? Let's break them down one by one.
First up in our rapid-fire breakdown is NOx, or oxides of nitrogen. The standard specifically defines this to include nitrogen oxide, or NO, and nitrogen dioxide, or NO2. But notice what the standard explicitly excludes here, N2O, or nitrous oxide. Why is that distinction such a big deal for accurate reporting? Well, because nitrous oxide is actually tracked entirely separately as a greenhouse gas under the Kyoto Protocol. NOx, on the other hand, is a specific class of highly reactive nitrogen compounds. When these compounds settle locally, they can severely degrade air quality, contributing to acid rain, and reacting to form ground-level ozone right where they're emitted. Right alongside nitrogen, E&P companies also have to track SOx, or oxides of sulfur. This category focuses heavily on sulfur dioxide, or SO2, and sulfur trioxide, SO3. The SASB framework points to these sulfur compounds as absolutely critical concerns for local air quality. Think about it. When a facility is running, especially during intense operational processes like gas flaring, or when they're running heavy diesel-powered extraction equipment, these compounds get released directly into the local atmosphere. They are notorious for causing respiratory irritation and environmental damage, posing an immediate operational challenge that companies absolutely have to measure and mitigate. Then we've got VOCs, or volatile organic compounds. I actually love how specific and technical the standard's definition is here. It describes them as compounds of carbon that participate in atmospheric photochemical reactions. Basically, these are complex carbon compounds that literally react with sunlight in the atmosphere. It's like a chemical recipe for dense, dangerous local smog. But again, precision really matters in this standard. The reporting framework explicitly excludes carbon monoxide and methane from this specific category. Why? Because it keeps the data laser-focused on these specific, smog-producing reactive compounds that can blanket local areas and just drastically tank air quality. Finally, let's zoom in, literally on a microscopic level, to PM10, or particulate matter. The standard defines this as airborne finely divided solid or liquid material with an aerodynamic diameter less than or equal to a nominal 10 micrometers. Okay, to put that abstract number into perspective, 10 micrometers is just a fraction of the width of a single human hair. Because they are so incredibly tiny, these solids and liquids are dangerously sneaky. When inhaled, they don't just get caught in the throat. They completely bypass our body's natural respiratory defenses and lodge deep within the lungs, posing direct, immediate, and severe physiological threats.
So the crucial takeaway here is that these aren't just abstract chemical names written on a chalkboard somewhere. The SASB standard puts it incredibly bluntly. Impacts on human health may be exacerbated if E&P operations breach air emissions limits close to population centers. That single sentence really hits home the severe human stakes involved in this data. I mean, it's one thing to operate a sprawling rig out in the middle of nowhere, but as drilling and extraction operations push closer and closer to where people actually live, work, and play, the localized health risks of breathing in NOx, SOx, VOCs, and PM10 rise exponentially. Suddenly, this data has very real faces attached to it.
But, the stakes aren't just physiological. They are fiercely financial. Beyond human health, there is a massive business story here, detailing the financial bottom line for these corporations. The standard notes that the financial consequences companies face from these air emissions vary wildly depending on the exact location of their operations and the prevailing air emissions regulations in that specific jurisdiction. Amid increasing public concern, breaching these limits doesn't just harm communities. It triggers major regulatory backlash, devastating financial penalties, and huge operational risks. Plus, if investors see a company constantly breaching local air limits, that can directly threaten that corporation's access to future capital. There is a brilliant positive feedback loop at play here, though. It's not all doom and gloom. And it's not just about playing defense to avoid fines. When companies actively invest in air quality management and upgrade their tech and processes, they aren't just shielding themselves from regulatory penalties or protecting local lungs. They're actually streamlining their entire operations. By achieving higher operational efficiencies and modernizing their equipment, they can realize a significantly lower cost structure over time. So, doing the right thing for the local air quality ultimately translates to creating a leaner, more efficient, and structurally more profitable business in the long run. Now, to achieve this operational efficiency and properly comply with the reporting standard, companies have to cast an incredibly wide net. They must painstakingly account for direct emissions across multiple operational sources to calculate their total metric tons per pollutant. And let me tell you, tracking this is a massive logistical puzzle. It means gathering data from stationary and mobile equipment, think massive drilling rigs and fleets of off-road vehicles. It includes the actual production facilities, meaning the complex processing and extraction sites themselves, and it even extends to transportation fleets and corporate office buildings. Literally every single source, big or small, has to be integrated into that final metric tonnage. But that begs the question, how do we actually know these final numbers are real? Transparency relies entirely on accurate data. To meet these stringent standards, companies use specific, highly rigorous calculation methods. For instance, they might deploy continuous emissions monitoring systems, or SEAMs for short. In practice, this means installing highly calibrated physical sensors directly on the exhaust stacks to provide real-time, continuous data. Alternatively, they can use complex engineering calculations or rely on mass balance calculations to track input versus output. It's a highly technical, uncompromising process designed to make sure the exact metric tonnage of these local pollutants is captured accurately and, most importantly, without bias. Which brings us right to our conclusion. As standardized data and mandatory reporting frameworks finally reveal the previously unseen pollutants circling oil and gas extraction sites, what does it actually say about the air in your own community? Corporate transparency, local accountability, and rigorous regulatory frameworks are deeply, inextricably connected to the very air we breathe. By forcing companies to relentlessly track and publicly disclose non-GHG emissions like NOx, SOx, VOCs, and PM10, we finally start to see the invisible. Thank you for joining me on this explainer, and keep asking questions about what's really in your air. Catch you next time.